This is Unit 6, Video 8, phase diagrams. We look at the phase diagrams. Phase diagram is a plot of pressure versus temperature. So we'll have temperature on our x-axis, pressure on our y-axis. It's kind of like this. So this is known for a lot of substances. They go out and determine what are the phases at various pressure and temperatures and kind of follow the boundaries. One of the things we thought coming to this point is that there's a boiling point and there's a melting point. Those are really standard boiling points and standard melting points. They're generated at 1 atmosphere. So we say the boiling point of water is 100 degrees Celsius. That's the boiling point at 1 atmosphere pressure. In Denver, Colorado, we know the boiling point is 92, 93 degrees Celsius, right around there somewhere. So in various places, we're going to get changes in temperature, we're going to get changes in boiling point. So what does our phase diagram look like? Well, generally we have 3 phases that we're interested in, solid, liquid, and gas. So we're going to have a phase diagram, in most cases, something like water, would look something like this, okay? So we've got the separation of phases. Now, at low temperature, low to high pressures, we're going to have a solid, okay? At higher temperatures but low pressure, we're going to have a gas. We know we can pressurize the gas and form the liquid. So those are going to be our 3 phases right there, solid, liquid, and gas. So a couple points we're going to be interested in. What is where these 3 phases intersect? We call that the triple point. Okay, the triple point is the temperature and pressure at which all 3 phases coexist. So if we maintain that temperature and pressure exactly, you literally will have water, liquid, water steam, and water ice all coexisting, meaning none of the 3 would go away. However much you had of each is the amount you're going to keep at the end. Okay, so we would have an equilibrium built there between the 3. Now obviously this right here is the melting line, the separation between solid and liquid, and the melting point, and this is a little high here, but the melting point of water is going to be at 1 atmosphere. So we know this is 0 degrees Celsius. And then we come over here, this is the boiling line. So this is boiling, while this is melting. Okay? So our melt line here, our boiling line here, 1 atmosphere is where we live, and that's what we call the boiling point and the melting point right there. All right? Now, the separation between the solid and the liquid continues up. This is not an ending point. The separation between the liquid and gas does not continue up. It stops at some point. We call that point the critical point. Okay? The critical point is the temperature and pressure combination beyond which there's no longer a boundary between the liquid and gas phase. That seems really unusual, but every substance has a critical point. So there's a critical pressure and a critical temperature. Normally we can take a gas, raise the pressure, and cross this line. That means we liquefy. We do that all the time. You have a container of propane for your grill at home. That container has liquid propane in it. Well, propane to gas. So we pressurize it and it liquefies. It works great. But beyond the critical point, there is no pressure at which the gas will condense into the liquid phase. There's no separation, no boundary between the liquid and gas phase the way we're used to. Also beyond the critical point, normally we can take the liquid, raise its temperature to some point, and it will boil. Not true. Once we move past the critical point, we can raise the temperature. There is no separation between the 2 phases. It becomes more like a gas as we raise the temperature. All right? The final point to make on the phase diagram is the lean of this line. The lean of that line will tell us relative densities. Okay? So if it leans over in this way, then we know if we're sitting at this point here and we increase the pressure, we're literally going to melt the substance. So if we pressurize the solid, we move into the liquid phase. That's because when we pressurize, we push the atoms together, we raise the density. The liquid phase is more dense than the solid phase in that case. If this line is tilted this direction, then when we pressurize, we move from the liquid phase to the solid phase. So the solid phase would be more dense than the liquid phase. Okay? So in summary, solid, liquid, gas, liquid's in between the gas. If the triple point is below 1 atmosphere, then we'll have a normal melting point and a normal boiling point. If this triple point rises above 1 atmosphere, we'll never see the liquid phase under normal conditions. Okay? So that's our phase diagram.